Okay, this is the ORRIBLE OOZE experiment. Now, ORRIBLE OOZE is a wonderful experiment. It's good fun to do. You're going to need some very simple ingredients, which are really easy to get. You're going to need some cornflower, also known as cornstarch, but usually in Britain it's cornflour, in America it's cornstarch. Now, it's made of tiny bits of starch powder, which is one of the reasons why it's called cornstarch. You're also going to need an empty bowl to mix with and another spoon. I recommend a metal spoon or a hard spoon because you're going to need to push quite hard sometimes, and if it's a plastic spoon it might bend. This is what I want you to do. I want you to scoop 2 heaped spoons of cornflour, maybe 3, but I'm only going to do 2 right now, but about 2. Then you're going to need some water, and that's all you need as well. And as you can see, this is just water in a little bottle, but this is ordinary tap water. I recommend using everything clean, so nice clean surfaces, clean bowls, clean water from the tap. I want you to just put a little bit at a time. So just a little bit first, move this out of the way, get your spoon and mix in and mix around. Now you'll notice I'm using a different spoon to the one I scooped the cornflour with because I want to keep that spoon dry so it doesn't get sticky. And I'm going to put a bit more water in and mix it around. Now you'll notice it's very thick. I can't actually stir it, and that's fine. But in a few seconds it will likely go a little bit more runny. As you can see, it's getting much more runny now as we mix the cornflour and the water together. Now remember, this isn't a chemical reaction, we're just mixing 2 things together. They're not joining together like chemicals sometimes do, they're just mixing. Now this is a bit too runny for this experiment, so I'm going to show you what to do if it does go too runny. I just want to make sure all the powder's mixed in well, as it is, and I'm going to add just a little bit more powder, but only a tiny bit, and you're going to notice I'm just going to sprinkle it. Just going to sprinkle it across the surface, only a little at a time. Because the problem is, if you add too much back in, you'll make it get all thick and clumpy and lumpy again, and we don't want it to do that. So going runny, actually, the good thing about going runny like this is it makes it easier to mix. So still not thick enough yet, so a bit more in. And remember, as you can see, I'm really only using small bits at a time, not a whole spoon at all, just literally a few shakes. Now this is getting more interesting already, although you won't see it yet. And as you can see, even from what I'm doing now, it's getting very thick, oozy. And I think you can probably see why I call it ooze. Now, that's not bad. Now, one of the tests to see if you've got it about right, of course you can see what I'm doing here, is can you scoop it up onto a spoon and pour it out like that, so that most of it comes up on the spoon. Well, this one probably is still a tiny bit runny, so I'll tell you what I'm going to do. I'm going to put a tiny weeny bit more powder in. And I'm glad it's working like this, it gives me a chance to show you what happens. Just a tiny bit, notice again, I just sprinkled a little bit on the surface and use the spoon to dig and mix it around. As you can see, you've got to keep a good grip on the container because it's moving all over the place now, but that's actually pretty good. That's mixed nicely. Now, I think you can see that it does actually look like a very thick, oozy liquid, and we can move it around. Okay. Now, one of the tests that you've got it right is, as I've already said, that if you can get a lump of it, and look, most of that is coming up and oozing off the spoon. So I think you'll agree it's definitely a liquid, just a very thick one. Another thing you could do, and I'm not quite sure how well we're going to pick this up, but we'll have a try, is if you hit the surface quickly, you might notice a little crack appearing, but the crack will disappear almost immediately. So watch again. Did you see that? So there's a little crack and a little dent, and it disappears almost straight away. That's a good sign that it's about thick enough, okay? Now, so we've made the cornflour in the way we want to. Next thing I want you to do is pick it up in your hands, roll it around in your hand, like squeezing it, like if it was a piece of plasticine, and then stop squeezing it and just let go and see what happens. But when you let go over the container, okay? So pick it up. I suggest using both hands, moving it around in your hands like this, rolling it around as if it's a piece of plasticine, and then just stop and hold it against the pot and see what happens. So, before I show you what I hope you would have noticed had you picked the cornflower up, I want to show you one more little thing. So I'm going to get a bit of tissue, just lay it on the table because I'm going to put my mucky spoon on it. So I'll just take the spoon out, so I won't need this anymore. And I shall leave the spoon there. Remember, good scientists always clean up after themselves. Now I need you to look carefully into here, and I want you to watch what happens if I put my finger in. So I'm going to put my finger in there, and when you push your finger in gently, it just goes in with no problem at all. As you saw, it goes a bit like a thick, oozy liquid. And when I move it very slowly through, as you can see me doing there, it moves through easily enough. It's very thick, but it does move easily enough. Okay? You can see the cornflour mix flowing around my finger. But watch what happens when I pull my finger quite quickly. What I want you to look for is the way the cornflour sort of breaks a little bit around my finger. Watch carefully. You can see it breaking. I'll do it again. So where my finger is dragging away from, it leaves a gap which quickly fills in. Watch again. Hopefully you can see that. So it's all sort of cracking and cracking apart behind my finger. Watch again. And filling in very quickly though, isn't it? Filling in again. So it seems that when I move my finger slowly, the cornflour mix flows around my finger without too much problem. But if I go to move my finger very fast, it cracks. It behaves more like a solid. And what you can't see, but what I can feel, is it's resisting me. It's trying to stop my finger moving because it's behaving like a solid. It's trying to stop me. Okay. Another thing you can try is pull your finger out slowly. And I'm not going to grip the pot this time. I'm just going to rest it on my fingers. You'll see, look at the way it's coming out. It comes out easily, oozes off my finger. Lovely. Then I'm going to put it back in slowly. And this time I'm going to pull it quickly. Watch what happens. It's gripping my finger. So when I do it quickly, again, it seems to be feeling like a solid. Well, it actually does feel like a solid. It's certainly behaving like one. It's gripping my finger. But if I do it slowly, it doesn't do it at all. Now watch what happens when I try and push my finger in quickly. It stops me. If I do it slowly, go straight in, no problem. So I think already you're getting some very good clues about what's going to happen next when I handle it. Handling it can get a bit messy, I'll warn you. So if you're going to do this one, make sure you do it in a place where you can clean up very easily. I actually recommend putting maybe some newspaper down as well, though we've got a lovely shiny surface, but I recommend you use newspaper and it's easy to clean up afterwards. So watch carefully, here we go, I'm going to scoop it out. Get a good grip, and you can see I didn't make too much because it's easier to hold. I don't recommend a huge amount, you don't need it. So I'm going to grip it. I've got quite big hands, remember, and I'm going to grip it. Now, you're going to have to watch very carefully as I move this around because you won't see very easily. But as you can see, as I'm moving it, I hope you can see that it looks a bit like a blob of plasticine in between my hands that I'm rolling. And in fact, I can squeeze it and move it backwards and forwards, a bit like a piece of soft, runny plasticine. So it behaves very much like a soft solid. Okay, and I can drop it. But watch what happens when I stop doing this. So remember, it's like a solid now. Watch what happens now. When you stop, it turns back into a liquid. It just flows off my fingers back into the pot. So definitely a liquid now, isn't it? And when you pick it back up again, interestingly, use a bit of force on it. Notice the word, use a bit of force. It goes back into a solid again. So it's actually reversible. You can make it go one or the other. Amazing stuff. So what's going on with ORRIBLE OOZE? Why does it behave in this rather peculiar way? Because remember, usually we often encounter solids, liquids and gases, for example water, ice, water and water vapour. It changes because we heat it or we cool it down. Now this is changing for a different reason. It doesn't seem to have anything to do with heat being added or taken away. So what's going on? First of all, let me tell you what you've made. Well, you know what you've made. You've made a mixture of corn flour and water. Now, scientifically, we would call that a suspension because you've got corn flour grains floating in, suspended in water. So, suspension, pretty obvious. It's got a rather more interesting technical name called a non-Newtonian dilatant thixotropic fluid, or some people just call it a non-Newtonian fluid for short. Well, what does all that mean? Well, Newton's a very famous scientist. He wrote lots of things about fluids like water and other common things, and they behave in particular ways, lots of fluids, but this doesn't behave like in that way that Newton describes, so we often call it a non-Newtonian. Second thing, dilatant. That word means stir thickening. So in other words, as you stir it, it gets thicker. You probably noticed that, remember, when we moved through it, it got thicker. So stir thickening, that's what dilatant means. Thixotropic, that means change by handling. Okay, so that's what that means. So it changes by handling. Of course, you've seen that too. And it is a fluid because it flows. Okay, anything that flows is a fluid. Even gases are fluids too, so they can flow. So what's going on then? Corn flour, remember, is little flakes of powdered starch. I mentioned this right at the start, so it's powdered starch. Now, if you could see powdered starch under a very powerful microscope, and it'd have to be a really powerful one, you'd see it's made up of tiny little packets put together, little particles, which we call molecules. So little molecules all joined together into big chains. I say big chains, they look big under a microscope, of course we can't see them, but long chains of molecules. And there's loads and loads, millions of them all moving around in here, and they're moving past each other. When you put water in and mix the corn flour with the water, a couple of things seem to happen. One is that some scientists say the water is actually going inside those tiny grains of corn flour and making them swell up a bit. But also what we think is happening is those little chains I just mentioned, those little chains of molecules, we think they start gripping each other and holding on to each other and becoming more rigid. And of course water gets trapped in between them as well. So by handling them, you're squeezing water inside the structure of the little particles, all the little molecule chains start gripping each other and holding on more tightly, and suddenly it won't move so easily. And remember, when you started gripping it and moving it, it became more rigid, more thicker. So that was what we think is happening there. And it feels slightly gooey and shiny and slimy because the water has been trapped inside. But of course, once you let go and you release those forces, all goes in reverse. The water flows out a little bit from away from the particles and all those little molecules, and the little chains of molecules come ungripped and just move apart a little bit, and it flows more like a fluid again. I already suggested to you some of the other things you could try, which I showed you myself, but which you might like to do by moving your finger around in the fluid. You saw me do that, but have a go yourself. Another thing you might try, which is actually quite fun, is maybe with a few other people, make a bigger amount, maybe in a small baking tray. Make a bigger amount, and then take objects, maybe little toys or bricks or anything really. Try and find things that float though, if you put them in water, so things that float, and rest it on the corn flour, and see how it floats in corn flour compared to how it floats in water. For example, how high in the corn flour it settles compared to how high in water. That's one thing you could do. Where on earth you'd see this is really interesting, because what you've done, you've made a model, if you like, of quicksand. Now we find quicksand, especially in tropical countries where there's lots of sand, but we also find stuff that behaves very similar to quicksand in countries like Britain and Northern America, where we have moorland and open grassland, where sometimes you get a hole forming and just the soil becomes more loosely packed and water gets trapped there. And then that soil and water mixture is all runny, and it behaves very similar to this as well. And I've actually fallen in some in Britain, so I know exactly how it feels. This behaves in the same way. And scientists often do model things. We make a copy of the thing we're interested in. So if I wanted to do experiments on quicksand, I could say, oh, well, I know this behaves like quicksand, so I can make my version, do my experiments on this, and get some ideas of how quicksand itself actually behaves. So for example, here's a thought experiment for you to try. You've done some experiments now and you've seen me use this. What do you think you would do if you came across some quicksand and you knew it was in front of you, too long to jump, but you wanted to get across it? What do you think is the best way, based on your experimental results? How would you get across that quicksand? What about if you're walking along and you didn't notice the quicksand and you suddenly stepped in it and sunk down to, say, up to your knees? Well, you're trapped for a minute. How are you going to get out? What's the best way of escaping that quicksand based on the experiment you've just done? So there's two things to think about straight away. Another thing you may have never noticed before, but which I'm going to ask you to notice, is tomato ketchup actually flows in a similar way. Now ketchup is much thinner, more runny, but I remember watching when I was a kid, I don't eat ketchup myself, but I know lots of people who do, when it came in glass bottles, and when they turn it upside down to pour it on their food, often nothing would happen. They'd be watching it, and then they start shaking like mad, and it doesn't seem to do much, and they get really upset and they start smashing the bottom of the bottle to make it come out. And often it was only when they stopped doing it, it would start oozing out slowly on its own. Does that remind you of anything? So when they're shaking the bottle, they're actually making it go a little bit more rigid in the bottle. And it was only when they stopped shaking, the forces disappeared and it flowed out just under its own weight and by the pull of gravity.